recording. Let's make sure I'm sharing the application screen. All right.
I'm not going to completely close this door because I know they'll be coming in, but I do need to get in place.
All right, so look at page M. We're going to review quadratics right quick. And then, like I said, we're going to review transformations. So we're on page M, and I'm going to start with the first three. So let's read what it says. It says, state the implied domain of each function. Okay, it's been a couple of days since we've done this, so let's look at our notes. This is our purple packet, and right here are the notes for implied domain, also called restricting the domain. So this is the area that we're looking at for numbers 1, 2, and 3. We talked about this. We know that it's okay to have 0 in the top. It's a no-no to have 0 in the bottom. That's undefined. So in math, there are two restrictions, or two ways to restrict the domain. Number one is you cannot have a 0 in the denominator. The reason is because of this, 0 in the denominator is undefined. And you cannot have a negative under the square root. Now be careful here, because sometimes I just say radical, and actually it's the square root or the fourth root. It has to be an even root. So this is the page that I'm looking at. I'm going to slide it over just so we can kind of look at both. I actually can probably get both up on the screen at the same time. Here we go. All right, here are the notes for this little topic right here. So number one, let's look at it. No negative in the denominator. Does number one have a denominator? No, so we move on. Number two, no negative under the square root. This problem does have a square root. And so what we've learned is that the stuff under the radical, just this, we don't care about anything else in the problem. Since it's in the top, it's okay for it to equal 0. So we put equal to 0. But it has to be positive. So it has to be greater than or equal to 0. We're only talking about the information under the square root. We don't care about the 3x or the plus 5. It's the 6x plus 13 that we have to restrict. Now, if you go to your steps right here, it says if the square root is in the top, which this is in the top, so that's why I set it greater than or equal to 0. So all you do, that pen is dying, I need to get another one. I say 6x plus 13 has to be greater than or equal to 0. Move your 13 over, it becomes a negative, divide by 6. X has to be greater than or equal to negative 13 over 6. That's the answer. This goes back to the first page that we took of our notes. Now, you don't have to do this, but I do want to remind you of what that would look like as an interval. This is good review because there's a lot of intervals on the final exam. So this would be a closed circle at negative 13 over 6. It would be shaded to the right. And if you wanted to write that in interval notation, it would be bracket at negative 13 over 6, comma, infinity. And then you'd put a parentheses. This is interval notation. I will accept either one of these, but I just want to refresh your memory on what intervals look like. We are going to connect this to the graph. If not today, it'll be next week. So that is number one. All right, let's look at number two. Now, these are the restrictions. We've got them on our paper. Number one, no 0 in the denominator. And number two, no negative under the square root. Okay, so we're looking at this problem right here, 5x to the fourth minus 6x to the 6x squared plus x minus 9. Do we have a denominator? No, so that restriction does not apply. Do we have a radical, square root? No. So no restriction applies to this problem. So if there are no restrictions in the entire world, what would you say the domain is? Correct. Negative infinity to positive infinity. Okay, Demario, what's another way to say it? All real numbers. You could say that. All reals. That's another way to say it. In other words, there are no restrictions in the universe on that particular problem. Now, what I hope to do in just a minute is I want to put these, I've got Desmos.com on my phone, and I'm going to put my phone right here, and I'm going to show you how this relates to the graph. It may not work out, but I'll try. All right, let's look at number 3. Go through your restrictions. Number 1, no 0 in the bottom. Do you have a denominator? Yes. So this right here, just this, we don't care about the top, but this cannot equal 0 because 0 in the denominator is undefined. The other restriction is talking about a negative under the radical, but we don't have a radical in number 3, so that has nothing to do with this particular problem. So all we have to do is say x squared minus 2x minus 8 cannot equal 0. We factor that. We have spent a lot of time factoring, and I have promised you that if you cannot factor, you're going to be in trouble, and that's true, because this one factors to x plus 4, x minus 2. No, that's opposite, right? Yeah, I'm sorry, this is supposed to be a minus 4. That's supposed to be a plus 2. Cannot equal 0 because, let me draw my chart out, 1 times 8 is negative 8. The middle term is negative 2. We've got to multiply together to give us a negative 8 and add together to give us a negative 2. So that would be negative 4 times 2 and negative 4 plus 2. I had my signs opposite. So this is going to be a negative and that's going to be a positive. Now, we're not finished. We have to complete that. Some people stop there, but you've got to keep going. So if x minus 4 cannot be 0, that tells me x cannot be 4. So there is a restriction on this particular problem. 4 is a restriction. And then the same thing here. If x plus 2 cannot equal 0, then x cannot equal negative 2. You could write that in interval notation, but it would be a 3-part interval. X can be anything, all numbers except for positive 4 and negative 2. All right, I'm going to try to put this one in Desmos.com really quick. It's 3x plus 5 times the square root of 6x plus 13. All right, so let me show you this one right here. I just put it in my phone. I want to show you how the restricting the domain ties to the graph. So I type this in, 3x plus 5, then I put my square root of 6x plus 13, and I've graphed it. Okay, that's the red line. Y'all see, y'all agree with me that I put the equation in? Okay, so let's look at the graph. What we said is that your x's are going to start at negative 13 over 6. Now let's see, negative 13 divided by, oh, hold on, my paper's slipping. Negative 13 divided by 6 is negative, let's call it negative 2.2. If you look at this graph, and you would probably have to zoom out on it a little bit, but this is going to be a shooting star because it's a square root graph. And look at the furthest most, because we've talked about domain, if you look at the furthest most x, now we said it had to be negative 2.2 or greater. What is the furthest tip to the left this graph crosses? See, if this is negative 2, don't y'all agree that that's probably negative 2.2? The graph does what we said. We said that this graph right here in red could not start before negative 2.2. And lo and behold, there's negative 2.2. The furthest most point to the left, the domain would be negative 2.2. All right, I'll try to put this one in. Okay, so 5x to the 4th minus 6x squared plus x minus 9. All right, so I type that in. And look at what it's going to do. Now, it's not a parabola. It has this weird little curly Q down there where it does something odd. But if you look at it, what does it look like it's going to do forever to the left and to the right? Right. It's going to go on and on and on and on and get wider and wider and wider for all infinity, which is exactly what we said. We said it was going to be all reals. And the last one is a little, I mean, it's more complicated to put in the calculator, so I'm going to stop there. All right, let's move on. Number 4. Now we're talking about quadratics. Another word for quadratic is parabola. Number 4, is the parabola opening up or down? You should be able to look at this. Somebody missed this on their quiz on Tuesday. How can you look at number 4? I'm not asking you to graph it. I'm not asking for the vertex or the roots or the axis of symmetry. I'm saying look at number 4 and tell me if it's going to open up or down. What is it? Down. And how do you know, Kayla? Correct. This is going to open down. It's going to be some type of downward quadratic. And the reason is because it says explain. Because it is a negative in front of x squared. If you want to add the fact that it's a negative 6, that's fine. But this negative right here tells me I don't know the vertex, I don't know the axis of symmetry, I don't know, I don't know much about it, I don't know the y-intercept, but I know that it's going to open down. If you get to your test in your quiz and you know it's supposed to open down and it does not, check your work. All right, number 5. Now this one's not in the order that we're used to, but what kind of x squared would this be? Positive. Okay, so this one's going to open up. It's going to be an upward U. I'm not trying to graph it, but it's going to open up because x squared is positive. So anytime we had a quiz last week or Tuesday, and it had a positive x squared. So that quadratic, if you didn't know anything else about the quadratic, it should have opened up. All right. Number 6, state the x-intercepts of the function. Now, don't overthink this. Let's go back to our notes where we talked about the x-intercept. Here's the x-intercepts, okay? All you have to do is plug a 0 in for y. An x-intercept is where it crosses the x-axis. So for your x-intercept, y must equal 0. So all I have to do to find my x-intercept is plug a 0 right here in for this y. That's like a y, this function notation. And then we set each factor equal to 0 and solve. So we're going to set this one equal to 0 and solve. 3x plus 2 equals 0. We're also going to set this factor equal to 0. We have 2 factors. It's going to cross the x-axis at 2 different places. So we have 3x equals negative 2 divided by 3. We move this over. We get 4x equals 12. Now I'm going to stop there and ask you why that is not the correct answer, and why if somebody leaves the answer like that, like they did on their packet last week, I'm going to take off points. That is not the answer, so don't put a box around it. Put our answers down here. That is how you get your answers, but it is not the answer. All right, y'all with me up to that point in time? Okay. It says state the x-intercepts. Intercepts are ordered pairs. They are coordinates. This is not an intercept. Okay, this is possibly a vertical line. It could just be a solution, but it's definitely not an intercept. An intercept must be in parentheses with a comma between it. So what we have to do, remember these are the x-intercepts, so we put a -2 in for x and we put a 0 in for y, and then over here we put a 3 in for x and a 0 in for y. These must be ordered pairs. Now we're getting ready to see on the next question something different. Notation really, really, really matters. If it asks for an intercept, that is an ordered pair. It needs to be in parentheses with a comma in between. Because on number 7, we're asked for something different, and the notation determines whether or not we've got a point or a line or an could even be an interval, depending on what you're doing. All right, so number 7, it says 2 points of a parabola are graphed. In other words, we don't know the formula for this parabola. We don't know if it's an up U. We don't know if it's a down U. That doesn't really have anything to do with it. It says, what is the axis of symmetry? Now, if you remember, let's go to our notes. The axis of symmetry is just x equals some number. It is a vertical line that goes through the vertex. So I can go ahead and write down, I know it's going to be x equals some number. I might as well write that down. This is a line. It is not a coordinate. It is not an ordered pair, but it is x equals some number. Now, we talked about, who did we talk about on Tuesday that has a perfectly symmetrical face? Beyonce. So if this is Beyonce's eyeball and this is her other eyeball, we know her nose has to come through the middle. In other words, if you come, let's see, 1, 2, 3 to the left, and then 1, 2, 3 to the right, if we move 3 in here and we move 3 in there, we're going to get where her nose should be. Now, we don't know exactly the coordinate of it, but we know it needs to fall somewhere on this line. This line is the axis of symmetry. It is the imaginary line that divides the quadratic or the parabola into 2 symmetrical parts. And so we want the equation of that line. It is a vertical line. We've already had an entire note packet on the difference in a vertical line and a horizontal line. It is a vertical line, and where does it cross the x-axis? Where does this? Right, -1. So the axis of symmetry is x equals -1. Okay. This is just, like I said, today we're mostly going to be reviewing because we're leaving here and going on fall break, and we've got to make sure that when we go home today, we got this purple packet straight, because when we come back Thursday, it'll be a different packet. We're moving on. We're not quite ready for our test, but we will have a different packet. All right, let's look at the next 3. Now, let me go back to our notes. There's several words that basically represent the same number. An x-intercept can also be called a root. It can also be called a solution. But an x-intercept is where it crosses the x-axis. So all they're asking you here is, how many x-intercepts do the graphs have? So if you look at this one, an x-intercept is where it crosses the x-axis. So how many times does that quadratic cross the x-axis? None. Because it says how many. So you can put 0 if you want to. Now, let me add a note here. This one would have imaginary roots, because we did one like that. It would have fake imaginary roots. You would be able to solve it using the quadratic formula, but it would have an I in it, and imaginary numbers are not real, so therefore it's not going to cross the x-axis in any real tangible way. All right, number 9, x-intercepts. They're not asking you what they are. It just says how many does it have. So it crosses the x-axis here, and it crosses the x-axis here. So how many is it? 2. And then the last one, number 10, it only crosses it 1 time. So it would just have 1 root, or 1 x-intercept. And for a quadratic equation, those are the only options you can have. You've either got no roots, you've got 2 roots, or you might have what's called a double root. In other words, that one, it hit twice. right, let's go to page N, because this is where we start practicing. All right, page N. Now, what am I, let's see if I can get, I might can get these two things up at the same time. Here are my notes, and this is my practice, and so we're going to do number 11 together. All right, here's your function, and it says find the following and graph it. The first thing we want to find is the vertex. All right, let's look at our notes because it's been a couple of days. To get the x coordinate, you do the opposite of b over 2a. First of all, you need to indicate what a is. What is in front of this x, even if you can't see it? A 1. Good. We had some problems with that on our last test. This is my b, and this is my c. So make sure you label that. This is your a, this is your b, and this is your c. If you do not see a number in front of the variable, it is understood to be a 1. Now, if the variable does not even exist, it's a 0. But looking at my notes, to get the x coordinate of the vertex, I do the opposite of b over 2a. I think this is helpful. I think it's helpful to actually label your a, b, and c. So if b is positive 2, what is the opposite of b? Negative 2 over 2 times a, which we just said was 1. So that's going to be negative 2 divided by positive 2, which is negative 1. Now that's not the answer, but that is the value of x. So we just found that the vertex has an x coordinate of negative 1. We are going to have to graph it, so try to leave a little bit of room around the graph. All right, back to your notes. To get the y coordinate, you plug x, which we just figured out, into the equation. So to get y, we take our equation, which is x squared plus 2x minus 3, and we plug in a negative 1. Now let me show you a huge mistake we are having right here. This negative 1 is squared. It has to be in parentheses. If you put it in your calculator, let me show you. If you put negative 1 in your calculator and square it, and you do not put it in parentheses, the calculator is going to tell you it is negative 1, and that is not true. Okay, so make sure if you're using your calculator, you have the negative 1 in parentheses, and then you square it. A negative times a negative is always a positive, and that tripped some people up on the quadratic formula last time when we had our last test. And then 1 minus 2 is negative 1, and 1 subtract 3 is negative 4. So now we know what y equals. So I've got x, and I've got y.
1 minus 2 is 1.
1 subtract 2 is negative 1. And a negative 1 subtract 3 is a negative 4. You have to do that from left to right.
Oh, I got my sign mixed up.
Yeah, this is very, very important algebra. I'll be perfectly honest. If you just type this in your calculator, as long as you use your parentheses, your calculator will do it for you. Negative 1, then square it, plus 2 times negative 1 minus 3, and the calculator will tell you negative 4. Now you have to put the parentheses in. That's crucial. But we are having algebra mistakes that are messing up with our pre-cal. All right, I'm going to put the answer up here just because I'm kind of running out of room. My vertex is an ordered pair at negative 1 comma negative 4. That's the vertex. All right, let's go back to our notes. The axis of symmetry is a line in Vernoc's form, in other words, a vertical line, and it just is x equals whatever you got over here. So since we got that x equals negative 1, that's just my axis of symmetry. So all I have to do for axis of symmetry is say x equals negative 1.
Axis of symmetry. So Could you explain that?
The axis of symmetry is what we just did on the front page. The axis of symmetry is the vertical line that goes straight through the middle. It hits the vertex, and it is equal distance from each of the, well, yes, in this case, each of the x-intercepts, but it's equal distance from the left-hand side and the right-hand side. It is the line that makes the graph symmetrical. So the left-hand side and the right-hand side are exactly alike. And it's always x equals some number, always. All right, let's look at our notes again. Let me see if I can get everything up there. For x-intercepts, we plug a 0 in for y, okay? So that means I plug a 0 and I set x squared plus 2x minus 3 equal to 0. This is a little factoring problem. We've got to multiply together to get -3. We've got to add together to get +2. Let's see, that's going to be 3 times -1 and 3 plus -1. So my factors are going to be +3 and -1. I don't have a ton of room. Remember for factoring, though, because you're going to get to number 12 and it's not going to start with a 1, you take the lead term, whatever this is. In this case, it's a 1, but in the next problem, it's going to be a 2. So just take whatever it is. So we put 1x in the front of each parentheses. One gets a +3, and the other one gets a -1. I think I can zoom out a little bit because I'm going to graph it in a second. Now, we're not finished. You are trying, we just did this on the front page. This was number, what number did I just do? Number 6 on the front page. But we have to solve, and we have to get 2 ordered pairs. The x-intercepts are ordered pairs. So we set this equal to 0, and we solve, and we get x equals -3. We set this equal to 0 and solve, and we get x equals +1. Now, those are not the x-intercepts because we have to write them as an ordered pair. So the x-intercepts, I'll put them up here, they are ordered pairs that go through the point -3 in the x position. So the first one's -3, 0, and the other one goes through 1 when y is 0. We have to write these answers as ordered pairs. This is crucial. Notation on this next test is humongous. And if you get a whole bunch of little -1s, -1s, -1s because you didn't have the right notation, there's 10 points right there.
Yeah, 3 and 1. That's why I messed up. I got 3 and 3. So I put 3 on that one and 1 on that one.
Because the factors are 3 and -1. All right, and then the last thing, let's go to our notes. To get the y-intercept, you plug a 0 in for x. So go to your formula, which is right here, and just take the formula, which is x squared plus 2x minus 3, and plug in a 0. Again, you can use your calculator for this if you need to. You can put that in your calculator. But what we end up getting is -3. Now, just like the x-intercept is an ordered pair, so is the y-intercept. So it has to be written as 0, -3. This has to be written as an ordered pair. Notation matters. Now, one thing that absolutely blows my mind is that you will have people, particularly on the test, that will get all of that correct. They did all of that work correctly, but somehow it's not graphed right. I just don't understand that. So, Kayla, help me graph it. What's the first point that you would plot? Okay, so that's fine. She says the axis of symmetry goes through -1 on the x-axis. So we're going to make ourselves a dotted line. That's the axis of symmetry. She's right. All right, what would you plot next? Okay, the y-intercept is at 0, -3. So go down 3 on the y. Put a dot there. Okay, so we're going to graph our x-intercepts. One is at -3, and one is at +1. And what's the only other thing left to graph? Very first thing. Vertex. So go to -1, -4, and there's your vertex. Now, if you look at those, like Demario said, and it does not look like Beyonce, if you've got one eyeball way skewed to the left or one eyeball that's completely jacked up to the right, your math is not correct. Graphing it is a good way to check your math, okay? Because if the graph looks whack, you're probably not right. But if we look at these, I can connect this with a nice, neat, I'm trying to find a different color, curve. Remember, it's not a V because it's not an absolute value graph. It's a quadratic, so it needs to curve. And that looks really pretty. And I know that I'm probably right because if we look at Beyonce's eyeballs, here's her eyeballs. And we look at her nose, she is equidistant. She is symmetric. All right, I'm going to skip 12 because I want y'all to work on 12. Let's go to the next page. Let's look at the 15, 16, and 17. Number 15, true or false? We talked about this. It's right here on this paper, so let me put this up here. True or false? The vertex is always the maximum. This is a picture of what I mean. In other words, the highest point of a function. Is that true or false? Is the vertex always going to be a maximum? No, that's false. Because what did I tell you it could also be? Right, it could be a minimum. It's not always a maximum. It might be a maximum, it might be a minimum. But it's not always a maximum. It's only a maximum if it opens down. It's a minimum if it opens up. All right, number 16. What is the domain? Now remember what domain is. Domain are the x values, and you're going to look at it from left to right. Your domain are your x's. So what is the domain of any quadratic function in ax squared form? Now be careful, this is a positive ax squared, so particularly they're talking about opening up, but it could also open down if your a was negative. So what is the domain of any quadratic equation that either opens up forever to the left and to the right or opens down forever to the left and the right? And what's another way to say that, Demario? Right, negative infinity to positive infinity, or if you prefer, you can say all reals. But a quadratic equation will always have a domain of negative infinity to positive infinity. Now, that's not true for the range, but it didn't ask that question, so. And then number 17, what is the difference between the axis of symmetry and the vertex? That's a good question. What's the difference? And we've kind of talked about that today. We've graphed them, we've calculated them. But what is the difference? You don't have to get super deep. What's one difference between the axis of symmetry and the vertex? Very good. This is a point or an ordered pair, whereas the axis of symmetry is a what? A line. That is correct. This is a line. This is a point. Remember, ordered pairs have to be in parentheses with a comma. That is very, very, very important. So the notation, they both are going to have the same x value because the axis of symmetry passes through the vertex. But the vertex is an ordered pair, and the axis of symmetry is just a line. Okay, let's see if I can pause this. Please, Lord, tell me I started the recording.